All right, so we've got the second example, y equals 3x plus 1, bracket 2x plus 1 all squared. Now, this is a case where it is possible to expand, but it starts to get a bit tedious. So we're going to call the first one u, and call the second one v. All right, so if we differentiate, now it can be a strategy to actually write out what they are. So I'll write u is equal to 3x plus 1, and u dash, as in the derivative of u, is equal to just 3, right? You differentiate 3x plus 1, you just end up with 3. V is equal to 2x plus 1 all squared. So v dash is going to be equal to, well, you bring the 2 down, 2x plus 1, well, to the power of reduced by 1, and then it's the derivative of what's on the inside, which is multiplied by 2. So it actually becomes 4, 2x plus 1. Okay, so we've got all the bits that we need for the formula to work. So if I do y dash, so it's vu dash. So, well, u dash is 3, v is 2x. So it's going to be 3, 2x plus 1 all squared. So that's my vu dash plus uv dash. So 3x plus 1, the function u, that one of the products function, times the derivative of the second, which is times 4, 2x plus 1. Now that's equal to 3 outside of 2x plus 1 all squared plus 4, I'll just put the 4 at the front, 3x plus 1, 2x plus 1. Now, there is a bit of a trick that we can do in terms of formatting or sort of cleaning this up. Currently, I wouldn't really want to expand it and simplify it, but there is something I could do. So we've got this common factor here. So I'm going to pull that out. So it's going to be 2x plus 1 outside of, what have I left with? Was 3, 1 lot of 2x plus 1, plus 4, 3x plus 1. Now, I don't have the 2x plus 1 there because I'm multiplying the whole things by it. Now, the last step I'm going to do is just expand and clean up this second set of brackets. So it's 6x plus 3 plus 12x plus 4. And so my derivative ends up being 2x plus 1, 18x plus 7. Now, that means that we don't have to worry about squares. We've sort of cleaned it up. It's a little bit time-consuming in that case, but certainly no more, probably less time-consuming than having to expand and then differentiate. And we wouldn't be able to get in such a neat form so easily. All right, let's try another one. I'm going to do 2 more examples. As long as you kind of go through and write the bits out that you need, it's a kind of reasonably helpful thing. Now, remember I did this thing, gx square root of, I think it was something like this, 2x plus 1. All right, so once again, I'm going to call this one my u. I'm going to call this one my v. Taking time to do this is important. U is equal to x squared. Now that means that u dash is the derivative of x squared, which is 2x. V is equal to the square root of 2x plus 1. Now, we need to write that as 2x plus 1 to the power of a half to differentiate. So v dash is equal to, bring a half down, 2x plus 1 to the power of, we'll reduce the power by 1, so it's negative a half, times the derivative of the inside of the brackets, which is 2. Now the 2 and the half, 2 times a half, they just goes to 1, so I'm just left with 2x plus 1 to the power of negative a half. Now for the moment, I'm just going to leave it like that. So y dash is equal to v u dash, so u dash is 2x, so we've got 2x plus 1 to the power of a half, I'll write it like that for the moment, plus uv dash, so it's x squared, times 2x plus 1 to the power of negative a half. Okay, so that's good. So if I then take out the powers of a half and make it into square roots, we're going to have 2x times root 2x plus 1 plus x squared. Now, this is where we need to do times. 2x plus 1 to the power of negative a half means the negative power makes it 1 over, the half makes it square root of 2x plus 1. And the last step is going to clean it up, 2x 2x plus 1 in square root plus x squared over square root of 2x plus 1. Now you could bring it together, so I will show you how to do that, but it does kind of become a bit more tedious, and anyway, we'll try it. So what I'm going to do is multiply the first one, top and bottom, by 2x plus 1. So this is going to be 2x root 2x plus 1 over 1, right? It's no denominator, it means plus 1. So I'm going to multiply top and bottom by the same denominator as the second term, which is the square root of 2x plus 1. Plus, and the second term I'll just keep the same. Alright, now the top, what happens when you multiply something, the square root by the square root? So say root 2 times root 2, you just get 2. So root 2x plus 1 times root 2x plus 1, I've missed the x here, sorry. So root 2x plus 1 times root 2x plus 1, I just left with 2x plus 1, not root of the square root. It's a full lot. So it's just 2x plus 1. Now the denominator, however, is the square root of 2x plus 1. And you notice that now it matches up. X squared over root 2x plus 1. If I combine them, I'm going to expand the first set of brackets. So I'm talking about these. I'm going to expand this out. So that's going to be 4x squared plus 2x plus x squared, that's my second term, all over the same denominator of root 2x plus 1. And the final step is just group like terms. 5x squared plus 2x over root 2x plus 1, which I guess in a way is neater. You could take another step and factorize out the x. 5x plus 2 over square root of 2x plus 1. There we go. That's another question that we could do. All right. Now we're going to do one last question and see how we go. So that was example 3. So we're going to do example 4. The key with all this, you know the tools of differentiation. You just got to watch your algebra and make sure at the start you set it up correctly, knowing exactly what's u and what's v. So let's go. F of x is equal to x over x squared minus 1. All right. Now, what is u and what's v? It doesn't look like. Now, we are going to do a thing called the quotient rule soon, but the way I could rewrite this would be x times x squared minus 1 to the negative 1. Because over here, this is just x times 1 over x squared minus 1. Now, if I have this, then I can think of this as my u. I can think of this as my v. And so I've got u is equal to x. So u dash is equal to just 1. Then v is equal to x squared minus 1 to the power of negative 1. So v dash is equal to, well, it's negative 1 comes down of x squared minus 1, reduce the power by 1, so that becomes negative 2, times the derivative of what's on the inside, which is 2x. So I'm going to simplify that, negative 2x, x squared minus 1 to the negative 2. So if I differentiate the whole of f, now remember, derivative f is just a function. What's the derivative finding is a gradient function. It's telling me a way to find the gradient at each point. So it's going to be v u dash. So u dash is just 1. So it's just going to be x squared minus 1 to the negative 1 times u dash, which is 1, plus u, which is x, times v dash, which is minus 2x, x squared minus 1 to the power of negative 2. All right. Now the first term is just the 1, obviously makes it the same. So it's just 1 over x squared minus 1 plus, okay, if I sort of group things together, it's going to be minus 2x squared times x squared minus 1 to the negative 2. Now, given it's plus minus, that's going to be a negative sign. 1 on x squared minus 1 minus, it's going to be 2x squared over x squared minus 1 squared. Now that's because this thing here is 1 over x squared minus 1 squared, and we multiply that by negative 2x squared, so we're going to end up with that. Now again, if I wanted to make it into one fraction, I would need to do the following. multiply the top by the same, so x squared minus 1 multiplied by x squared minus 1. That's how we change the denominator. I'm going to match up the x squared minus 1 to x squared minus 1 squared. It's going to multiply by another lot. So we're going to end up with x squared minus 1 over x squared minus 1 all squared minus 2x squared over x squared minus 1 all squared. Almost there. We group everything together over x squared minus 1 all squared, and that's equal to x squared minus 2x squared, so it's minus x squared minus 1 over x squared minus 1 all squared. Now we can't just start cancelling things. This doesn't actually match up. This is negative x squared plus 1, but that doesn't work. And so we're not going to go and do all sorts of try to cancel x's and things like that. So that is what we end up with as our answer. To be quite honest, if you'd end up at this point and you gave that, you most often would get full marks, and you're able to use that to find derivative. Sorry, I should have said the previous line. Okay, so see how you go with the exercise. Exercise 8.6, sorry, and see how you go with it.